Greetings, dear student. You are welcome to Honex Success Call. Honex Success Call is simply a program that is brought by a group of teachers, both for ordinary level and advanced level, to give you all the A grades that you desire to have in the GCE. And I am your host, Mr. Destin Emmanuel, your A-level examiner. And today, right away, we'll be treating A levels physics, A-level physics, paper 2, June 2020. Good. Okay. In June 2020, the first question that was asked in paper 2 of physics is the power P obtained from a wind turbine may be given by, we have an equation is given, P equal to K, we have L squared, we have rho, we have V cubed. Good. Okay, we need to know the meaning of each of the quantities here given. Each of the letters that we have to know what quantity does each of these letters stand for. We have P is being given as the power. P is actually the power. We have L is length of blades. We have rho, it is air density. Then we have V, it is wind speed. Okay, all the meaning of each of the meaning of each quantity that each letter represents in the equation is being given below. And now in A of this question 1, what are we asked? In A we are asked what is a homogeneous equation. Remember, this question is coming from physical quantities and dimensional analysis, the first module in lower seat. Okay, now if you get back to your notes which were given in class, a homogeneous equation, a homogeneous equation, I write equation in short form, is an equation whose unit is an equation whose unit of the physical quantities, whose units of the physical quantities on the left hand side are the same as those on the right hand side of the equation. Good. That's the meaning of a homogeneous equation. It is an equation whose units of the physical quantities on the left hand side of the equation are the same as those on the right hand side of the equation. Good. We go to question B. Question B is that determine the base unit of the constant K. This is the constant K. in this equation that was given in the question. So for us to actually get the base unit of k, the first thing we have to do is that we have to make k the subject of the formula in this equation. Remember, making subject of the formula is form 3 work. If you get back there, you are going to see that for us to make k the subject of the formula, we need to divide this equation on both sides by L squared rho V squared. So it will give us k being equal to P, which is the power, all over L squared rho. We have V to the power 3. Good. So P is actually power, and power, it is actually the work done per unit time. So expressing power in terms of units will be equal to, that's work done is actually the force times distance moved in the direction of the force all over the time, which is equal to, force is measured in Newton, and the Newton is actually defined as a force that gives an acceleration of a mass of a force that gives a mass of 1 kilogram and acceleration of 1 meters per second squared, and it should be multiplied by the units for distance, which is meter, all over the units for time. So just power we have as base unit kilograms meter squared per second cube. So that's the unit for power. We continue this way. We express by this. This implies that k now is actually equal to, we copy the base unit for power, kilograms meter squared per second cube, all over, we have the unit for learn, it is meter. So we have to square, just as learn has been squared. We square the base unit, we square, multiply, or the product of it, to the unit of measurement of density. Density is actually the mass per unit volume. So the units are given as kilograms per meter cube. Then the units for speed, we cube them. If you cube the unit for speed, it will give us meter cube per second cube. Good. So those are the units given like that. So we simplify. Kilogram will take care of kilogram, meter square will take care of meter square. We have second cube will take care of second cube. Then this is per meter, and this is also meter cube, so they will take care of themselves. So this implies that k is equal to 1. So what is the significance of that? Is actually to tell us that k is a unitless. K is a unitless. It's a unitless constant. So that's the meaning of that. So you have to indicate it there like that. Okay, right away we continue with the next question. That says C. Question C. It says state two shortcomings of using homogeneity to check the correctness of a physical equation. Okay, when you are using homogeneity to check the correctness of a physical equation, you actually realize that there are some aspects that homogeneity does not hold. For example, what are those aspects? Let me just put them on the board right away. So permit me wipe here. Let me wipe here. So that will take that C. Wipe here will take C. Okay. What are the shortcomings? We have C. The shortcomings are when you use homogeneity, you will realize that a homogeneity cannot be used to check the correctness of a unitless constant, like this one that we have had. K is a unitless constant. So we have some other unitless constant like pi and also angles. Okay, so you're right. The first point there is that homogeneity cannot be used